Okay, so this is the video for Lab 10A. This is your worksheet for 10A. You're going to fill this out, identify these components, and then your other worksheet that goes with this video is on the other side of this. And I'm going to take some measurements. This is worksheet 10B, and we're going to take some measurements as we go through this alternator. And you're going to record them, you're going to write them down, and you will see the reading on the meter, and you will hear me talk about them, and you're going to fill out the sheet, and then of course you're going to submit the two of them online. So let me just set my timer here so we don't go over. We're only given half hour by this camera to do these videos, and it shuts off. Okay, so I have an alternator. Actually, I have two of these. One you can see together. One I've torn apart. Okay, so this actual alternator, when I was tearing it apart, really does not lend itself to rebuild, at least not in the shop. I think you need some special equipment to get this thing apart in one piece for sure. I didn't have that here at home, and I ended up breaking the case to get it apart. But that's okay. I just wanted to show you the internal components and discuss them a little bit. So you can see on the front of this alternator, which has become fairly normal for modern vehicles. Now this is a fairly new alternator. This is out of a, I believe, between, let's say, 2009 and 2012 Chrysler vehicle. Okay, so this is made by Denso, and you can see right on the side the sticker for the manufacturer is still there, and we can see Denso written right across the bottom here. Okay, so most alternators should have a sticker like this, especially if it's an OE alternator, which is going to give you some information on it, amperage, charging, and manufacturer, part numbers, and so forth. Okay, so we have a one-way clutch on the front. That's fairly standard for most alternators. Now this alternator has been sitting for quite some time and is starting to seize, but we can see that it rotates in one direction, which it's designed to do, freewheel, and it locks in the other. Okay, so that's not a fault of the pulley right now. This has just been sitting in my garage for about 5 or 6 years, and it started to seize up, that's all. Okay, it's not ever going to be put on a vehicle. It's just for what we're doing right now, demonstration purposes. So we have the one-way clutch. These pulleys are replaceable. Okay, there's a plastic cover here that would come off, and there is a bolt inside you would take off to get this off of the alternator. So if you needed to replace just the one-way clutch, you would be able to do it, depending on the location of the alternator, maybe without even removing it from the vehicle. Okay, so should lock in one direction, freewheel in the other. Very similar to the way we took a look at the one-way clutch on our starter drive in the previous video. Okay, so put that out of the way for a moment, and we'll look at our components here that we've taken this one apart. So I've taken it apart down to its base components, and we'll talk about each one separately. So here are the main components of an alternator, right here. Okay, so there is basically the main components of this alternator. Everything else is just there to hold it together and connect things. So we have our stator right here, and this is a delta wound stator. Okay, I do not have a neutral junction on this. This is a delta wound stator. This would be my rotor, and my slip rings, of course, at the end of the rotor. Okay, this piece here, this bracket, is actually a housing for the bearing. The bearing is pressed into this and pressed onto the shaft. I don't have a press at home, so I wasn't able to get that apart, but that's fine. You get the idea. You can see the slip rings clearly. One is going to be positive, one is going to be negative, and there is my rotor coil inside between my claw type pole pieces. Okay, I have my rectifier bridge here. So this is my output stud, right? Right here is my output stud. So this would be my positive rectifier bridge on top. This one here, you can see this actually grounds right to the inside of the case, and this is my negative diode bridge. Okay, so I have a positive and negative diode bridge. Now most alternators are going to have about 6 diodes. This one has a few more because of the configuration of the winding. Okay, so in this case I have 1, 2, 3, 4, 5, 6 positive diodes, and I have 6 negative diodes as well. Okay, so in this case I have 12 diodes in total, 6 positive, 6 negative. My brushes, this would be my brush holder, and we can see the brushes are inside here. I can push them down, they're spring loaded. Okay, and they would ride on the slip rings here at the end of the rotor. Okay, this would fit over that. Of course, it's inside the end here. I'll take the cover off the end of that and you can see it after. Okay, now this is the connection. This would be like this inside there, and there's my 2 wires going into it. Okay, so this is simply an electrical connection in here. These alternators are computer controlled on this vehicle. So the PCM in a Chrysler, as you remember from our theory class earlier, the PCM controls the ground side of this alternator. It's going to have ignition feed going to one terminal and the PCM controlling the other to ground. Okay, so that's my brushes and my brush holder. Now this is actually removable, and I'll show you on this other alternator here once we get the end cap off of it. So what are some electrical testing? Now this alternator, like I said, I'm sure they're being rebuilt somewhere, but whomever is rebuilding them is going to have special equipment to get them apart. Just taking them apart in the vise was very difficult, and of course I ended up breaking some of these components. So obviously now if you look at the wires coming off of the stator, they are actually designed to come up through the bottom of this, and this is actually where the stator windings go. And they connect into the rectifier bridge, of course, because the rectifier bridge is the output. I have an AC signal or an AC voltage coming out of my stator, and it goes through my rectifier bridge and leaves the output stud as DC voltage. So what are some things that we are going to test here? Well, very similarly to when we tested the armature in the starter motor, we're going to test the rotor in a very similar manner. So we'll put the rotor here and right in the middle. Okay, and some of the things we're going to test on the rotor, the first thing we're going to do is we're going to touch each slip ring and make sure we have continuity through it. Right, so we can see here, let me get a good reading here for you. Okay, we have 1.8 ohms. So I have 1.8 ohms of continuity through one slip ring, through all the winding, back to the other slip ring. Okay, the other thing we want to do, just like we did with the starter, we want to touch the slip ring and make sure that we have no continuity to the pole pieces. They should be separate from each other. Okay, so I have no continuity, and I want to make sure, once again, I have no continuity to the shaft as well. Okay, so that should be open circuit, both my slip rings, open circuit, and once again, no continuity to there, but continuity through the slip rings. Okay, and I'm going to have continuity from my shaft to my pole piece. I should have anyway, not that it matters, but generally they're not insulated from each other. They are in this case. Okay, but the big thing we want to worry about is we have continuity through the slip rings and no continuity to the shaft. The other thing we want to do, we want to look at the slip rings, make sure that they are nice and clean, in good condition, no grooving or wear, an indication that the brushes have worn their way into it. like I showed you on the other alternator, right? We can see now the connection here a little bit better with that case missing, and you can see the alternator attached to the rotor. Okay, the rotor is what spins in the alternator. The stator does not move. Stator means stationary. It stays in one piece. It's attached to the inside of the case. The rotor is the moving component. Right, so the rotor rotates. I'll hold on to the rotor, and we're just simply going to check our one-way clutch. So this one's much smoother than that one. And you can see how easily it rotates and locks in the other position. So it's going to lock that way, rotate freely in the other direction. Okay, so that is the rotor. Okay, our other main component is our stator. And our stator windings, now this is a delta wound stator, which means that the windings are not all connected as they would be in a Y wound. In a Y wound, I should have continuity through all of my windings back to the neutral junction. I don't have a neutral junction here. Now you can see I've put green and black tape on these, and that is to indicate what I have continuity through. So if we look at the meter here, I will simply hold this onto 1, and then I'm going to touch the ones beside it. So I have 0.3 ohms, and then I'm going to go over here and touch this one. I have 0.3 ohms. Okay, I have no continuity, however, to the other winding. They are insulated from each other. Okay, and I also have no continuity to the frame of the stator, which I don't want. That would be a short to ground. How would it become shorted to ground? Well, if it became overheated, which is one of the common failures when an alternator is overworked, the stator is the part where all the heat is generated. This is the part where all the work is done. This is where the voltage is induced into, and it leaves through the rectifier bridge out to the vehicle. So this is a part that gets hot. Right, if we're charging a dead battery on a hot day, this is a part that is going to bear the brunt of the work, and this is a part that's going to overheat. And what can happen with these when they get too hot, of course, is the solder connections can melt, and the varnish on top of these can melt, and they will short to the frame internally. Okay, or if it's touching the housing on the other side, it could short to that. So we need to make sure that it is not shorted to the housing. So that's my green ones. I have continuity through them. And now we're going to turn this around. We'll check the black ones. So we'll go to this guy right here. And then we'll touch each one in turn. 0.3 and 0.3. Okay, so once again, I will make sure I have no continuity of the frame on this winding either, which I don't. So we can see that this alternator frame, or this stator, is in working condition, other than the fact that I damaged it taking it out of the rectifier bridge. So some alternators lend themselves better to rebuilding than others. Okay, this one here is very, very difficult to get apart, and I wouldn't recommend you try to do it in a normal shop. This would have to be done in a rebuilding shop where they have the special tools required to get this thing apart and back together so it can be in working order. The last thing we have here to check electrically is our rectifier bridge. So like I said earlier, this would be my positive rectifier, my positive diodes. This is my output stud. The bottom side would be my negative diodes. So we know that a diode allows flow in one direction only. Okay, so what we're going to do, we'll start with the positive diodes. And what I'm going to do is I'm going to touch one side of the diode with my lead, and actually I can just touch the frame here because they're all attached into the frame. And then touch the other side of the diode. We can see it coming up here with my meter. Okay, now we also have to make sure we're on the right scale. And I should have no continuity in one direction through any of them. As we know, a diode only allows forward bias, which means it only allows flow in one direction. So now I'm going to reverse my leads. We'll put my positive lead here on the frame. And I will go through and I will touch the other way. We're going to have to change our dial a bit. There we go. So we have continuity. It's quite high. We have 16,000 ohms. So we're on the 20K scale. And I should have continuity all the way around. So those are my positive diodes. And then if I reverse my leads, I should have no continuity. So we will grab our case here again, and we should have open circuit all the way around this. Okay, so that is good positive diodes. I have no continuity in both directions, right? So it should only flow in one direction only. So now I'm going to rotate this, and we're going to look at the other side. So now I'm simply going to grab the negative case, and we're going to go around and touch these diodes. Okay, and I have no continuity in this direction. Oh, there's one there. I have continuity through. Continuity there. Let me just double check these. Okay, that makes sense. This bottom or this ground plate is in two pieces. So I'm going to have to check it in two different locations. So I have continuity there, there, and there. So I'll reverse my leads. And we will try it again on the other direction. Open, open, open. All right, so now I need to rotate this and check the other side. Okay, so we'll leave that there. So these should all be open in this direction. Okay, so that is my three diodes on this side. We'll reverse the leads for these guys. And once again, I should have continuity through them. There we go. So we have 15,000 ohms. 15,000 ohms. So we have roughly 15,000 ohms through our diodes. One direction only. Of course, a diode, unless it's a Zener diode, should not allow flow in reverse bias. Forward bias only. So that's the electrical checks that we would do if we were going to rebuild this alternator and put it back into service, or rebuild any alternator. We would do the same electrical checks for that we just did with this. Okay, so that is our torn apart alternator. So we'll bring this one back into focus here, and I'll take the end cap off here. Okay, so we can see the configuration of this, how it sits here. So there's my rectifier bridge. Of course, my rotor is inside, attached to my pulley, and my stator is under here. So we can see, looking at the rectifier bridge here, we can see the stator coming through, right? And I can see the stator connections. This would be the leads of my stator. So if I put the stator here beside it, right, these leads coming up here are actually these leads on the stator. And this is actually configured like this. So we can see these two here, that would be these two here. We can see these two here, that would be these two here, and these two would be these two over here. Okay, so this would be my brush holder right here. This is my electrical connection from the PCM into the rotor, right? Our only control over the alternator is rotational speed and our field, magnetic strength over magnetic field, which we're controlling by, in this case, duty cycle on the ground side. So the PCM is turning it on and off, ground, unground, ground, unground, and it's controlling the alternator based on other inputs into the PCM, such as temperature. It's looking at ambient temperature. Some vehicles will have a battery temperature sensor. They're looking at state of charge of the battery. They're looking at other accessories that might be put on the system. And the PCM is controlling the state of charge based on the demands of the system. So if I have low demands, of course, it's not going to be charging. It doesn't need to, unless the battery gets down to a certain level, and then the PCM is going to see that, and it's going to turn the alternator back on. So we have much more control now over the charging system than we used to when we simply used an electronic voltage regulator, and before that we had mechanical voltage regulators. Okay, I didn't talk about mechanical because they've been gone now for 20 plus years. We've had electronic module or voltage regulators with the Zener diode that we talked about in theory. We've had them for about 20 plus years, and now of course everything is becoming controlled by the computer. Now in the case of Chrysler, it's strictly computer control. In the case of other vehicles, it could have both a voltage regulator and the PCM, and the PCM is controlling the voltage regulator. Of course, an electronic voltage regulator on a PCM and regulator type system would no longer have the Zener diode. It wouldn't need it anymore because the PCM has taken over the role of the Zener diode. The PCM is simply going to be instructing the voltage regulator when to turn on and off the alternator and the magnetic field. Okay, so you should be able to complete both of those sheets based on our discussion today. Anything that you can't find the answer to in the video, go take a look in your textbook. Okay, all of the information is there. All right, so that is the end of this video. Get your sheets filled out, get them submitted so I can mark them today, and I'll see you tomorrow.